Good morning, everybody. Thank you for attending. This event's being recorded, and we're going to go through a couple of big topics here. First of all, you've got a lot of marketing systems. Your data is everywhere. Ganesh is gonna walk you through in a minute, and we'll get into the agenda, but we're gonna dig into how companies in the real world are using artificial intelligence, machine learning, for data science in the marketing analytics domain. So let's go to the next slide, and you'll see our pictures. I'm Grover. I'm the one on the left there. I'm a mathematician. That's usually a warning, but in crowds like this, it's not too bad. I'm a math and topology expert. I did grad school with math and quantum electrodynamics. If you find that even slightly intimidating, please don't. I'm a plumber. I deal with modern data science tools. We have a lot of tools at our disposal. I deal with a lot of business data. My specialty is business and retail and marketing and sales data. I have done some work in biogenetics, epidemiology, pharma, but I primarily come back and work on business data systems. Over to you, Ganesh.
Thanks, Grover, and thanks for having me on your webinar today. Really excited to share some thinking around how you can get your data ready to do some of the elegant modeling and predictive analytics that Zepl is really great at. So my background is in the SaaS world, in software as a service startups, working with small companies and big companies. Prior to that was in consulting, and Grover, if math is a warning, then consulting probably might be as well. So yeah, take no harm. I've since converted to being a person in industry. I lead product marketing for a number of our go-to-market activities at Snowflake, and I'm really excited today to share some of the learnings on the Snowflake side around how different customers are using Snowflake and Zepl in marketing analytics use cases. So I'll flash forward here a bit on Snowflake. The background here, we're the cloud data platform. Essentially what our platform does is takes disparate data sources like all of your customer data. We pipe it into a single source of truth, a single copy of data that then makes it active for a number of different use cases. In terms of marketing analytics, the workloads that we support, everything from data engineering to data warehousing, data science, these all support marketers in a number of different ways. You can see them here on the screen. Ultimately, what Snowflake does is we make the data available for concurrent use. We can scale up your compute resources on a per second basis so that all of your use cases are fully supported. And when it comes to data science, we know that power is key. Getting to personalization in real time can change the difference in a customer engagement from being very personalized to being actually quite poor. So that's one of the key use cases that we see on the marketing analytics side, which brings me to Zepl. And Grover, I'm super excited about the Zepl partnership overall. You mind just giving us a minute on how the partnership works and a bit of the integration? And I think you're on mute again.
Zepl is a data science notebook in the cloud. We're scaling this all the way up from what used to be kind of a kick the tires approach with notebooks all the way to end-to-end production. And one of the first things I've been doing for years, not this year, I mean for maybe 5 or 6 years, is telling people we have a bad habit in the history of data science of using a bunch of flat files and losing our work, leaving it unsecured on laptops, not being able to share it. And so what I tell people is, and I'm sure this doesn't sound real modern to you guys because you've cloudified everything, but I tell people use a proper database. And one of the characteristics of a proper database, of course, is that it's available, that it's fast, that it's secure, and that you can reach it anywhere in the world. So what we do is we have data science notebooks. You can put modeling in there, you can train the models, but then unlike most notebooks, you can actually go into deployment, and that's where you'll be really glad you're hooked to the live data in Snowflake because it's available anywhere in the world and it's fast and you're not going to run out of resources. So we'll dig into more of that, but that's how we work together. So the agenda today, we're really in 2 parts. Ganesh is going to deal with the something that Snowflake has become a true expert in, a domain expert, which is marketing data, how you deal with the data strategy. And in my world, we always start with the word, don't tell me about the project, let's start with the data architecture. What kind of data do we have? How are we going to access it? Where's it stored? How does it relate? And so Ganesh is going to dig into some of the experience and technology that Snowflake has developed. Then I'm going to take some of our joint customer stories and talk about how we deal with both descriptive and predictive kinds of analytics and modeling and deployments. Over to you, Ganesh.
Perfect. Thanks, Grover. And so, yeah, so setting the foundation with the data strategy, to set the context here, as Grover said, in order to really get the value from your data science investments, you really need to bring data to bear in a seamless way where your high investment resources, your talented data scientists aren't spending time munging for data, right? Cleaning that data, bringing it together. Instead, they have the data available. But oftentimes that understanding isn't there in the organization. And this is a bit of a humorous view at the take, right? Many organizations come down from the tops, from the CEO, CMO, perhaps saying, this is the year, everyone, we're going to be data driven. And, they look at maybe some reporting from Google or eConsultancy or McKinsey, the Bain BCGs of the world. And they see that being data driven leads to business growth, and that's great. And they feel great, we nailed it. We're going to be data driven now. We're going to really use our full wealth of data to drive our business. How do you think that makes data scientists and marketers feel? I know in speaking to our customers, when they hear this, they feel like they've been just dumped on by a pile of bricks. No one's sitting around at home trying not to be data driven. In fact, most marketers have been trying to be data driven for the past 20 years. Certainly, we've been investing in new and more effective ways to leverage the data. But the challenge ultimately isn't the need to be data driven. It's the fact that we have fragmented data sources. Just here on the right-hand side, Salesforce is reporting that over the past 2 years, they saw a 50% jump in the number of data sources that the average team is using. And fewer than half of teams feel like they have a unified view of all their customer data. So when it comes to actually leveraging the data, having that unified view is almost the first step to making that possible. A bit about the why of why this is such a challenge. I'm sure many folks have seen this before. When it comes to capturing customer data, the MarTech explosion has created a vast macro world of all the customer data. Every touch point and more complex, nuanced journeys is being stored in different parts of the customer journey in these SaaS applications, let alone your internal data. And that data is only growing exponentially, right? So ultimately, if this data is fragmented, it creates a big challenge for organizations to get value from it, right? So when it comes to doing really targeted engagements, it's hard to do that if you can't enrich your customer profiles and create those deep segments, whether you're doing one-to-one on a data science basis or even something more preliminary. When it comes to optimizing those engagements throughout the customer journey to maximize lifetime value, that becomes a gap. And when it comes to attribution measurement, when Grover speaks in a little bit around some different models to really measure ROI, it really is important what data you're bringing into that model so that you're capturing all the different touch points across channels. And so a lot of this just isn't possible unless that data is in one place. And if you're not breaking down these data silos, a lot of investments don't realize their full potential. So I'll quickly cover off on 3 steps to bringing your data together, right? So it's pretty basic. Integrate your data, store it in one place, and then make it available for sharing across all your use cases. And I'll fly through some of this because I know a lot of the content, the richness is going to be bringing it to life in the customer stories in a minute. So let's first talk about integrating data, right? This is a view on some of the data that might exist in your ecosystem that you already have, but maybe aren't leveraging to the fullest potential. The first is often first-party data. So data that exists in your internal systems, your virtual 4 walls, so to say. The second is data that you're bringing within and out of with your second-party partners. So strategic partners, folks that you work with that have data that's unique to your relationships, your joint relationships with customers. A common example here might be brands working with their retail distribution partners. And finally, we talk about third-party data, or data that you can procure from the ecosystem to enrich your customer profiles and do a better job of creating customer segments and driving greater engagement. And so these, at each level, there's different data silos that need to be broken down. And it can be very onerous and challenging to try to tackle it all at once. But we recommend thinking about these 3 levels and thinking about what do you need to win in an incremental way in order to ultimately drive the value through your modeling. And briefly, how do you go about doing that? One, when it comes to integrating data, we work with a ton of ETL partners, integration partners, and you can see some of the views here. Briefly, things to consider before working with the partner. Think about the coverage and making sure that you have all of the relevant data sources captured, that you're not going to have to build things on a one-off basis or go to engineering or do it, roll up your sleeves yourself to make it happen. Two, when it comes to simplicity, being able to manage the integrations on your own so that in the future, when you bring in new data, you can use the tools that you've procured to make that possible. And then three, if you already have pre-approved vendors, that's going to dramatically reduce the time to value. So you can get up and running pretty fast. One area I wanted to quickly highlight, which is the opposite of moving data to integrate data, is actually sharing data. And the Snowflake Data Marketplace is a great option for third-party data. Essentially, thanks to all of the data being in the cloud, once data is on Snowflake, you can access that data without ever having to set up a data pipeline. And this dramatically changes the game when it comes to sharing data without moving data, which means reduced risk for all parties involved. The data lives where it needs to live. There's no copies of data. It also is much easier to maintain that data. So if an API or an ETL pipeline breaks, in this world, you don't need to manage that. In fact, once the data is refreshed on a partner site, it becomes instantly available in your ecosystem. So I think this is a great opportunity for third-party data. So let's flash forward and talk about now storing it in a central place. I won't get into all the detail, but I think it's important for folks to walk away understanding that not all data platforms are built the same. It's incredibly important to have one single platform where all of your workloads can be concurrently used, and you can scale to make sure that a data science workload isn't going to conflict with a analytics use case, and so that at any single moment in time, all of your use of that data is possible. And I think there's a lot of buzzwords in the ecosystem right now, and a lot of people are using the same marketing lingo. Ultimately, my advice is take a screenshot of this and test it for yourself and make sure that you're able to run all of the use cases you need in a cost-effective way, in a way that's easy to manage. And then the third piece, just to quickly touch on, is sharing data, right? And we talked a little bit about this earlier, that in order to then bring the data into your analytics models, whether it's analytics, whether it's ad hoc analysis, or more programmatic data science, you're going to need to make that data available. And again, the antiquated way of thinking about this would be actually copying files and maybe flat file uploads into a system. We know the pain of that, right? It's costly to maintain, it's error prone. Working with pre-built partners with Snowflake like Zepl dramatically changed the game here. That data is just instantly available, a few clicks through the Partner Connect ecosystem, and that data is always fresh, it's live, and you'll be up and running in minutes. The last piece on data sharing is if it's, for one-to-one use cases, one-to-many use cases, or many-to-many, I think it's worth it for this audience to investigate some of the use cases that you need to activate your data, especially if you're thinking about marketing use cases. And then again, test and make sure that the data platform you're investing in can support all of this in an effective way. I think there's a lot of confusion in the marketplace between what data platforms can do and what they market they can do. So again, if I leave you with one thing, it's think about your overall needs and please go ahead and get under the hood and test it. So I'll leave you with just these three thoughts, right? So what we talked about, data in silos is never going to be useful for your organization. You're never going to be able to run some of these fancy models that Grover is about to jump into. And you really need to take these three steps, right? Integrate the data, store it in a single place, and enable access to all of your different workloads at the same time. Grover, with that, I'm going to hand it off to you here. And I'm excited to see some of the real life stories here from our joint customers.
Okay, and I'll share my screen here. Hopefully it's going to let me do that. There we go. and share. And right here, look at me, I can use PowerPoint. Okay. Okay, you guys can see my screen okay? And let me make sure I'm in the right place here.
We can.
We're good. Okay, so let's dig into some of the real life stories. So in the first day of a statistics class, and I'm a mathematician, not a statistician, but statistics does some really useful stuff. And in the first day of the class, they told you two things. They told you statistics is about counting, and that counting is hard. That's one thing. The other thing they told you is that statistics does two things. It analyzes what happens in the past, and then using completely different methods, it has some predictive ability of the future. And that's what everybody wants in marketing. So what we want is we want to deal with descriptive, that is, get my marketing data together, tell me what happened, tell me what worked in general, and then we'll put a modern data science spin on it, train some models. Let's train some models to know what to look for. Then let's move to, can we be looking at live data and as Ganesh said, doing something as real time as changing customer recommendations based on something the customer did 5 minutes ago or 2 minutes ago, to making sure that it's customer personalized. Can we direct our ad money to the right ad campaign? So let's dig into this. There's two big environments and they're completely, totally different. There's the B2B sales and marketing world, which is driven by customer relationship management systems, you know, Salesforce, Oracle CRM, Sugar CRM. You know, got some kind of big CRM out there. Marketing automation systems, and there are a huge number. And without trying to pick one or knight one, there's only one out there that deals well with databases much bigger than about 1 million records. Most of them don't. Why? Because they're built for B2B scale. You got outbound calls, emails, you got trade shows. You know, we wish we could have trade shows. We have a sales cycle, and this starts to affect things greatly. Let's slow down for just a second and tell you one huge difference between the B2B world and the B2C world for marketing. In the B2B world, something I did 2 years ago could be driving a sale that's about to happen right now. Now, technically, in the B2C world, advertising from 2 years ago can cause influence, but truly, in the B2C world, most of my actual sales cycles are measured in hours or minutes. And so the scale of the time domain is very different in sales marketing in B2B and sales marketing in B2C. In B2B world, we have a lot of difficulty in attribution, but we still try. And we also have a complexity here, although you have some of this with parent-child products in B2C, primarily in B2B, we're selling to organizations. So we need to track what's happening with all the people in a company, not just the one person we're talking to right now. In B2C, as Ganesh's picture showed very well, we have distribution channels. We have to deal with things that are not in our control. We have products displayed in multiple storefronts, both physical and virtual. We can have hundreds of millions of people we're tracking. We have a lot of complexities with search engines, repeat customers, paid search, direct email. The sales cycle is often a single visit, which means that single visit is use it or lose it. When someone's visited your online store, you do not want to depend on them coming back. You want it to sell now. We do have difficulty in attribution, and we're usually trying to sell to a person, not an organization. This requires different data collection, different models. Machine learning and data science are only vaguely related between B2B and B2C. I've never seen the same exact model work in both. Descriptive, this is ROMI. It's a rear view mirror. It's basically looking at what did work in the past. Predictive is what people want to get to. They want to say, I would like to use machine learning to change my advertising, or at least tell me what to change in my advertising. I want to move where the puck's going to be, not where it has been. So we want to do both of these pretty quickly, and we want to make sure we do descriptive. You do have to do descriptive first. You can't just say, give me some of that machine learning stuff and hook it up to my ad campaign manager. You have to take a look at what did work in your world. And even two companies with almost identical products could have completely different descriptive histories depending on what they did. We're going to talk about ROMI. This is return on marketing investment. It's about 18 years old. It's really a millennial thing. Its first real use was around 2002 in Guy Powell's book. And it's a pretty simple formula. What it's not is an ROI in the traditional sense. ROI, return on investment, is a CapEx model, and it compares investment CapEx to yield. You can always retain some CapEx assets unless the house burns down. ROMI is an OpEx model, operating expense, and the investment is 100% at risk. You could spend $1 million in marketing and get nothing. It's gone. So ROMI is really measuring something different than CapEx ROI, but it's still pretty darn useful. The formula is really simple. Show me what my change in revenue was times my margin, and then subtract out what I spent on a program, divide it by the program spend, and it'll tell me what my ROMI is. It'll tell me basically what my model is. So for example, let's suppose I went and got $1 million in revenue, and I spent $100,000 in marketing. Well, I'll take $1 million, subtract 100,000, that's 900,000. I divide it by 100,000, that gives me a ROMI of 9. And so companies are looking for ROMIs. They would prefer to have ROMIs in the small double digits. Almost nobody has ROMIs in the large double digits. There are two kinds of ROMI, and you'll hear a lot of people touting both kinds. Fuzzy, I mean, no offense to this, it's not a negative term. Long-term ROMI is what's called brand capital. And brand capital is when someone does a brand awareness or brand positivity. They're trying to measure the benefit, quote unquote, of your entire marketing. 95% of the projects I am asked to work on are sharp ROMI. Tell me where we spent money unless it's working. Tell me if it's working, track the inputs, tell me if we got sales from it, and show me that in a business cycle sense. Don't tell me about 5 years. Tell me about the money I spent in 2019 and the revenue I'm getting in 2020. That's considered sharp ROMI. You do have to separate out existing from renewal. A lot of mature businesses are only really interested in renewal business because they don't get that many new customers. So they dig down into show me how marketing helped to drive renewals and upsells. Most tech companies are interested in new business. They want to know, show me what activities bring me new customers. And so depending on the maturity of your industry, you may care more about upsells, renewals, and customer retention, or you may care about new sales to new customers. Online stores, by the way, will tell you they make most of their money off of repeat return customers. And that's where most of the love goes. And you probably noticed that with online stores. They don't work as hard to get your business. They do love new customers. What they really want is to make customers satisfied. High-tech companies want new customers. Let's dig into one of the things we use data science for, and this is, by the way, typical of the kind of customers that Snowflake and Zepl have in common. They often want to go, if they're doing huge deals, they want to go in and look at, show me exactly what happened in a particular deal. And so possibly for the first time in your life, so let's slow down for just a minute, you're looking at what we call single stream. And you'll hear that word in data science a lot. Some of the pictures that Ganesh showed are how you get to single stream. And what you do is you collect all this amorphous data, you get it into a database that can scale, like Snowflake, exactly why we're talking with you about this. And then you'll just isolate it down to show me all the events in all time for a customer. In this particular case, since this is a business-to-business sale, it is an opportunity, relatively large, that moved from historical down to a closed won condition down there at the bottom. So old time is at the top, new time is at the bottom. And here you can see something that you can't tell anywhere else. You know how sales and marketing often disagree whether the deal came from sales or marketing. I'm sure nobody in this call has ever heard that argument, but just pretend that there is such an argument. This clearly shows this particular deal was first initiated by marketing. And over on the left-hand side, where we've isolated the marketing events, you can see something you never see on the right-hand side. And this is one of the purposes of data visualization. Anybody here who hasn't taken Edward Tuftay's course, please go take it, data visualization. But the punchline, after 2 days of watching Edward Tuftay do magic, he'll give you the truth. The data have to tell you how to be presented. You're looking at something you may have never seen. It's called a champagne chart. And its purpose is to show you marketing events often create pack behavior. You'll see 5 different people did the same thing on the same day to start this. Scan down to right where the deal was created, down there where it shifts from red to purple. Again, 30 people from the same company showed up at the same webinar. That happened right after the deal was turned from a prospect into an opportunity. And then you can see marketing goes quiet like it should while sales is doing its business. Then without marketing doing anything, end users are coming in and participating in the content, and it races down to the close where the sales activities in a flurry and the closed deals. This is what a multi-million-dollar deal looks like. Now, why did I explain all of that? Because mostly we're not looking at single customer, we're looking at cross customer, but we do want the ability to visualize a single customer that is a unique thing to do forensics in good and bad deals. Here's the opposite kind of deal where you can see the first activity was a sales call. And then very, very early, it went from red to purple. The salesperson said almost immediately, we have an opportunity here. So we shifted from prospecting to selling. You can see most of the behavior here, since this is a sales-driven deal, is over on the right-hand side. But you can see those stripes again that you never see on the right-hand side, but you see on the left, where 50 people do the same thing on the same day because they were stimulated by something that happened on the sales side to all go download the same white paper, all go see the same webinar, all go pull the same document, all go visit the same website. So this kind of visibility tells you you validated, and by the way, if you can't see these data in your system, then you don't even know if you have the event data. But you do need to single stream it, sales and marketing together. That's the T in ETL. You need to transform data and tag it and say, this was sales data, this was marketing data, this event happened here. The other thing you want to have, by the way, which is a religion with me is, and I've got several customers that aggregate their data, and they'll take the events and they'll aggregate them by day. Don't do that. Leave the timestamps on that. If I don't have a timestamp, I can't tell if a phone call caused a web visit or if a web visit caused a phone call. I got to have the timestamp down to the seconds. I don't need the milliseconds, but frankly, in e-commerce, there are times when we can only debug problems with milliseconds. So do not trunk date times. It's worth saving. The database will hold it. You need it. Okay, what else do we do? We use pattern fitting, a type of machine learning that will, and artificial intelligence that'll go in and find pattern fitting. You can see the curve at the bottom is a second order polynomial, it's curve fit. This particular one comes from a particular type of curve fit. This particular one is a Holt analysis, and that brings up another topic. Most of the algorithms we're looking at came from the 40s, 50s, and 60s. Very little in data science other than topology is new, but the math is now applied with massive databases, fast networks, cloud containers, smart notebooks, and good programming languages. What this picture is showing is the deal was won, and these were all won deals down in the lower right-hand corner. That's day 0. Everything before that's negative time. So 360 days before, people were doing evaluations, and you can see that this is a pattern of how people consume product evaluations for a SaaS product before they buy it. And you can see a fair number of people are more than a year. So some people evaluate a product more than a year before they buy it. This is part of the B2B conundrum, what marketing interactions actually led to the sale. It's a lot. By the way, in this one, little deals at the bottom, really big deals at the top. And you can see even for some really big deals, people are up there evaluating a product 60 days before they buy it. So there are quick sales even in this world. White papers in general, don't take this personally, are awful at being associated with sales. They're throwaway consumables. They very seldom drive a sale, very seldom become the attribution king for a sales cycle. Well, and by the way, I could have shown you 50 models, and that's one thing we do. When somebody says, what's the best algorithm? It's like, you give me your data, let me cycle through 50 of them, and I'll tell you which is the best fit and the best predictor. Can I guess in advance? Sure. For certain kinds of data, we can usually say this model or that model or another model particularly works best. There are about 200 popular artificial intelligence pattern fitting models. There are lots of different kinds. We'll talk about that in a minute. But first of all, you have to get the data. And Ganesh already talked about a lot of that, and I'm not going to dig into it too much. You have to get access to all systems. You see that bullet there, getting access to all the systems? That's weeks. If you get that overnight, you're the CEO. It takes a lot of time to get all permission, to find out where all the systems are, and go from there. Okay, after you've gotten the data, at some point you want to go to what I showed you. I showed you those champagne charts to convince you want time-based data that can get you all the way down to a person, organization, and sale. On the right, use a proper database. Do not store your stuff in flat files. Don't put it on a laptop. Plan for it to scale. So even if you're just kicking the tires, start with a database. Please start with a good one. Start with a cloud one. We really like Snowflake because it's fast, it's cloud. So if we want to transfer a project from Europe to the United States for analytics, the data is already achievable. And it's not if it's in your data center. It needs a cloud expert to do that. Your data center database may be 50 to 100 times slower if you try to get to it across an ocean. Then you subset and model the data. You want to do those models I showed you, and I realize that you probably want a tutorial on how to do that. Ask, and we'll do that. We'll actually go through live data and have a little tutorial. It's pretty geeky, but you want to identify what success looks like. You want to identify the population regardless of success. By the way, don't call them losers. You want winners at the top, and then you want everybody. Don't try to say people who didn't buy. Just compare who won with everybody, including who won. It's a better model. You benchmark it. You want to show the difference between customer demographics, between buyers and non-buyers, inbound attribution campaigns, in-cycle behaviors, all touch points by time. Please keep the timestamp, not just the date. You want to find the patterns and train the models. You want to go from broad discovery algorithms to deep learning, and then you want to find the best fit. And then you're all done, and you present your metrics for phase one, which is those charts I showed you are phase one ROMI charts. Here's what we found. Here's what's working. We have trained models now. Now, models and probability matching. One of the things you do, like when you train a model, and I pick pictures because people can relate with it, we'll give an AI system 100 million images of cat. It's very important to give it images of not cat. Make sure you put some stuffed toy cats in the not cat. Otherwise, your model will have been trained to train cats. How does this relate to business data? Point your data at things that are these deals won, and then point your data at here's the general population, not necessarily the losers. So make sure your data knows the difference between these deals won and these deals were just visitors, generic visitors. Once the model is trained, depending on your data and depending on how good the model is, it'll take a picture of a cat and it'll give you a probability. So what you want when you're all done is a model that can tell you, here's my prediction, and here's the probability that it's right. At the bottom too, by the way, you can see the same two pictures identical, except one of them has lost some information. Therefore, the probability is cut in 1/3 that my model can guarantee it's a cat. If I can't see the head, I can't tell it's a cat. How does that relate to marketing data? A lot of times in business to business, if you completely switch the buyer from the people you talked to in the beginning to the people who are dealing with the deal completely mid in the middle, like the key buyer leaves, you're just like a headless cat. You can't tell what this deal is going to do because the buyer changed. I have no history on what this person's going to do or has consumed. It makes a big difference. And again, as I put a note on the bottom, think about this in terms of stuff that came from the period between 1935 and 1965 when most of these algorithms were invented. A lot of the pattern matching comes from information theory and Dr. Claude Shannon's paper on information theory in 1948. Models that curve fit. By the way, most of the models that curve fit came from people like John von Neumann, who basically modernized Fourier transforms into usable. And if you have enough data in discrete information, your AI will look at that top set of data and say, I recognize that. That's called root mean square. Anybody who's ever had an oscilloscope recognizes that curve. In the real world, because we lack things. And how do we lack things? So your customers are accessing your website on their phone, and your Marketo didn't cookie their phone, so you can't see all the instances. So what you'd like to have looks like the top curve, or it looks like the middle curve. And why does that matter? Because the polynomial that fits the data is much more complex and computationally expensive. Then you get down to that bottom data. That bottom data is actually just one of those curves coming down from the descending root mean square. It's about to pop back up. But if you looked at it in isolation, you'll say, this is going to 0. Nothing's happening here. When in fact, what it's about to do is rebound. And what you're looking for is a probability cone, like that little green cone in the middle. Most machine learning models create one of those on their forecasting. If I screenshotted 100 Zepl notebooks, you'd see that little cone 100 times, because that's what curve fitting and then prediction looks like. So get your data into a proper database. Sure, some of it will always be messy. Some of it, like for natural language processing, will just be text stream data or audio data. But where you can, put your data in a proper database. Remember that most data science algorithms are working on what I call square data anyway. They're looking at basically at table data, and they're mostly looking at it in memory. You're going to need to move to a proper database anyway, because you want to do this with live data. You want to hook your systems up so it's not a one-time extraction, so that you've got live data streaming into a database, and then you can hook it into the system. Here's one of the challenges that was brought up by Ganesh. Don't store your stuff on roving laptops. Your most expensive, valuable data can be everywhere. It can be stolen. It can be walked out the door by an employee. Make sure you're keeping it in security. And this, by the way, is one of the reasons why you marry notebooks like Zepl with Snowflake, because then we can have trusted people who have what we call the secrets, the access to the data files and credentials, and they can share the output with people who can't even see the database. That's very useful. So we use the notebooks a little bit as the presentation layer for the results of data science to the end users who may be business executives. There could be thousands of people who see the notebook, but only 2 people know the secrets to log in. That's why you want this in a proper place. Live data. You need a picture like this. Left-hand side, all your sources. My CRM, my advertising systems, my storefront, my ERP, inventory systems, marketing automation, point of sale. I want that going to an input engine. You usually need something like a Zepl transform engine. You use notebooks to transform the data. So we'll have a proper ETL. By the way, Snowflake has a lot of really cool connectors that do a lot of that ETL work for us. But sometimes we need a little bit of nudge, a little bit of logic to turn it into the kind of data that's in that blue database in the middle, and there it's single stream. Then you want a modeling engine that's constantly retraining, and it's taking yesterday's inputs and turning it into the day's predictions, forecasting, product recommendations. You can feed this back to your marketing campaigns, spend more on these ads, spend less on these other ads. It can shove to your online store. Here are the most popular products. That goes into the product recommendation engine, goes to finance. Here's the forecasting based on what's going on. You want a universal engine, and you do want it in a live database, just like we're showing, with live engines that can do it. And one of the nice things about using those live engines is you eat them by the drink. You pay for them by the drink. They only run when they need to. So you're not paying for containers and resources you're not using. You're only paying for what you're using for at that moment. That's true, by the way, with Snowflake and with Zepl. You're kind of paying on consumption as opposed to just for static infrastructure. As you scale up, you want lots of pieces. You do not want to build one huge application. You probably want 50 notebooks. It's nice to have a single database, and it's nice to have many modules. You only want to wake them up when they're needed. You only want them to run when they're needed. That's one nice thing about using the Zepl notebook model. You only pay when they're running. That's very helpful. You don't pay for idle resources. And then if you need to modify a module, you modify it in isolation of the rest of the system, so you haven't broken other stuff. And you want it to scale. You want the ability to scale to huge size, but you only want to pay for what you're paying for. By breaking up into modules, each module is the right size for the job it needs. And if you can, you want to stay in the notebook world. Some people like to leave the notebook world and say, oh, I built the code of the notebook, pull it out of there, put it in the data center. What do you have? untrained models. You took your models, you deployed them, the data changed, and your model's not changing with it. Stay in a data science notebook where you can retrain the models in production, retrain them daily, retrain them weekly. You're always deploying fresh information. You're not dealing with static models. It's a great combination. The cloud database and the notebook model is actually working. People are doing this today, and it works really well. So, Ganesh, how are you doing?
I'm just zoned in, Grover. Thanks for sharing some of those use cases.
Okay, Elise, do we have any questions? Are there any questions for myself or Ganesh?
We do have a couple questions. So somebody said, so you mentioned data science notebooks. We use both Jupyter and Zepl notebooks. We confess that, yes, many of those live on individual laptops rather than a central location. You know, what would I do? How would I use Zepl or Snowflake to standardize and get a handle and security around these notebooks?
Well, I'll tackle part of that. And part of the, by the way, part of the security answer is Snowflake itself. We actually recommend that you take the secrets from those Jupyter notebooks. So if you got a Jupyter notebook, probably somewhere on your local machine, there's the secrets, how to access the database. We recommend that you put that into a connector and that you put the secrets into a trusted database so that they're under administrator control and not sitting around on someone's laptop. The other thing is we can just take and import Jupyter notebooks or Zepl notebooks. It works fine. The history of notebooks is a common history. There are a lot of features here that you do want to go beyond that Zepl does have that productionizes this. I guess that's a verb I made up. But you know, you want to move away from stuff that's on laptops to stuff that's on the cloud. I'll give you an example in my world. 3 years ago, I was paying $3,000 each every time I upgraded my laptop. Every time. I now am able to work for 2 weeks in a row on a $300 laptop. Why? Because the tools in the cloud are faster, better, more secure, and more reliable. It's just better. And so get away from the $3,000 laptops, you know, and having a big disk in your home apartment, and use cloud notebooks and the notebooks in Zepl notebooks, and it works better. Hope that helps.
Cool, thank you. How do you access data from Marketo and Salesforce?
They're very different. I think, Ganesh, you guys actually have connectors to a lot of these systems, don't you?
Yeah. Speaking about both of those specifically, I know that, you know, a lot of different ways you can bring Marketo data into Snowflake. It's a very common structured database. Sometimes you can get unstructured JSONs as well from your general marketing channels, even beyond Marketo. There's ETL solutions that you can use that are pretty effective at bringing that data into Snowflake. And then speaking about Salesforce particularly, I know Snowflake and Salesforce have had a great partnership, especially with the last round of funding. And there's some connectors that are available for beta today. And in general, moving forward, there's going to be some great data sharing across those two partners. In general, I would highly recommend looking back to the slide around how do you choose the right ETL vendor, going back to ensuring that you've got the right connectors. They're easy to use, they're self-serve, they're not custom code based, but point and click based, so that you can have the kind of flexibility going forward.
And it does save a lot of time. People like me used to spend 80% of my time doing that. And people like Snowflake have built technologies so that the time I spend on that is now down to a couple percent instead of 80%. The other thing is, I would motivate you to do it. In the case of the motivation for moving Salesforce data into Snowflake, it's just access. You get better access. You move Marketo data into Snowflake because Marketo doesn't keep events past 90 days anymore. And that's key. You want to have a record of for B2B sales, it could take you 2 years to close a deal. Marketo's keeping the events for 90 days. And that's one of the motivations for keeping key events and putting them into a database.
Great, thank you. Grover, this question's for you. If we don't have much data science or engineering experience, what can we do? Where do we start? What kind of team do we need to build out?
I wouldn't recommend, and this is hard, this is a tough question. Companies can't start by hiring data scientists. Usually you need to go back to the profession that Ganesh talked about. You need to bring in some consultants who know what they're doing, prove to you the benefit of what you can do. Because for a company to go from zero to data science me with internal people is usually really hard. What you need to do is say, I've got a project. I don't have huge goals. I got a project, and I want the project to be a proof of concept that we can get some benefit. That project will have to do a fair amount of the work we just talked about, but by constraining it and literally by leaving some of the systems out, you shrink the project down to be successful. Then once you've learned where it is, you now know where to bring in data scientists. And I will caution you about data scientists. Most data scientists who have any experience are domain experts. They know a particular kind of data really well. I'm okay with epidemiologic data, but with business data, you know, all those systems that Ganesh showed, I know them all. Every one of them. And you don't get that if you have someone that's outside your domain. So the skills are common, the models are actually very common, but actually the domain experience. And so I would say, start with a project, find a small data science team who can do this, and go from there. But there is a model to bring this all in-house, and that's where the notebooks come in. Once you know what's going to work, then you want data scientists. And by the way, I will also say this, good business analysts who've been using tools like SAS for years are really data scientists in the making. The jump from being a business analyst or a BI person to a data scientist, I don't know, it's 100 hours of training. It's not that bad. So, you know, that's where we can, and if you email me, I can point you to how to get started, depending on your domain.
And Grover, is that also something Zepl can help with if someone were to identify, here's a project that I have, sort of where do I start? Who are the consultants that I should bring in?
We actually have some consulting partners. So yes, we can help. We can point you to consulting partners. You know, for some certain partners, we actually, I mean, Snowflake and Zepl right now are working jointly with consulting projects for certain customers, usually slightly larger customers, but yes, we can help. But, you know, in a literal sense, getting connections in the data science world is not that hard. So connect us and we'll try to connect you with people who can help you.
Great.
Grover, I thought I'd,
go ahead.
Go ahead.
No, I thought that was a great question, great response, Grover. I thought I'd add to that. One thing that we've seen on the Snowflake side is a bit of a maturity model when it comes to getting started in this space. I know the person asked specifically around data science or data engineering resources and where to get started. The first step we often see is just getting a 360 view and doing some of the descriptive analytics that Grover was speaking to. Understanding where are your quick wins, where do you want to invest, taking a step back and understanding the landscape of the potential, right? Then there's kind of three options from there, right? And these are the most common ones. There might be others. One is around getting a better understanding of ROI attribution. So I know Grover spoke about ROMI and a couple other different models. You can start with descriptive and then get deeper with data science on attribution pretty quick. I'm sure many people are already doing attribution analytics. It's not like you're going from 0 to 1 there, but you're bringing more data from your 360 view to make that ROI analysis more productive. And then you can get into more campaign optimization, right? Get into better subsegments of your customers. Again, starting with descriptive analytics. And then finally, you can get to deep personalization in doing real-time engagements across all of your channels. Grover said this pretty well up front, right? Starting with data science, when you are using the definition of data science as multi-channel real-time personalization, might be a recipe for disaster because you're basically out of the starting gates at 100 miles an hour without even a seatbelt on, right? So take a step back, understand what data you have, your customer 360 view, and then start figuring out what are the right investments to make.
Great. And then just one last one, Grover, what models work best for campaign analysis? What kind of machine learning models work best?
Let me give you an answer I usually give when we talk about mass testing A/B test subjects and emails. I've deployed probably 250,000 email subject tests in the last 5 years. And people say, you do this a lot. Which subject do you think is going to win? I don't know. That's why we test them. And really the same answer is true with data science. Get the data in a place you can iterate across it and then study it with as many models as you can stand. I usually plan for big projects on using 50 different kinds of models until we something that has what we call an R value that says this model works the best to fit these data. And it varies. Now, I will give you a little bit of hope. Once a model is proven to fit your data, it usually just needs to be retrained, not replaced. So, and this is, I mean, this is a subject of 2 days worth of lectures, how to iterate through models. And that's one thing you'll notice. There's not one model. There are hundreds and hundreds of data science pattern fitting predictive models.
Awesome. Thank you, gentlemen. Super great content. I don't think we have any other questions. Thank you, everybody, for your attendance and your questions and your time. And Ganesh and Grover, thank you so much for sharing your expertise with us today. Have a great day, everybody.
Appreciate
Thanks,
it.
everybody.
Thanks, everyone.
Thanks.